The saying, "you are what you eat," could perhaps be more accurate if it was, "you are what your mother ate." We are beginning to understand the importance of maternal nutrition in short and long-term health outcomes for the child. In the short term, adequate nutrition in pregnancy is needed to ensure babies are born full-term and at a good body weight, and to keep mothers healthy throughout pregnancy. It is also important in the long term. If your mother did not eat enough while pregnant with you, then as an adult, you are at a significantly greater risk of developing type 2 diabetes, obesity, and heart disease. So mothers need more energy and nutrients in pregnancy. One of these nutrients is protein. Protein is comprised of 20 amino acids, and one of these, lysine, is the topic of my research. But why lysine? Well, lysine is an essential amino acid, meaning we cannot make it ourselves, so we have to get it from food. Lysine is also the first limiting amino acid in plant proteins, and this means that relative to all other amino acids in foods like wheat and rice, lysine is found in the lowest amounts. This has significant implications for populations who are heavily reliant on these foods as a protein source. And populations in developing countries typically fit this profile. They are therefore at an increased risk of lysine deficiency, which is associated with decreased immune function, increased diarrhea, and increased stress. And stress in pregnancy could be a lecture in itself. So we should know exactly how much lysine is needed in pregnancy. But we don't. Current recommendations are a calculated estimate based on male data. There are no direct data. And this is not a massive oversight. Studying protein and amino acid nutrition is incredibly challenging, and traditional techniques are invasive and are actually unethical to use in pregnant women. So instead, my research uses the indicator amino acid oxidation technique, a newer method that looks at another aspect of amino acid breakdown. When you are missing just one amino acid from your diet, your body cannot make new proteins. It's like you're missing a puzzle piece. All other amino acids have nowhere to go but to be excreted via a process called oxidation. At low lysine intakes, we see loss of oxidation in other amino acids. No new proteins are being made. As lysine intake increases, we see a drop in oxidation, and eventually a plateau is reached once the requirement has been met, meaning we can make as many new proteins as are needed. Where these data break from a negative slope to a plateau, we find the lysine requirement. And we have found this to be 30% higher than what is currently recommended for pregnant women. These findings will have global implications for maternal and childhood health outcomes. With these data, we are defining a requirement for lysine in healthy pregnancy for the first time, adding another piece to the puzzle that is maternal nutrition. Thank you.